Hello world, welcome to my Woofer project walkthrough, a full stack MERN app with a CI/CD pipeline from GitHub deploying to EC2. Let's get started. So this video is going to go through a live demo, then I'm going to go through a technical deep dive, how I built it, and then lastly, a couple engineering challenges, what I learned during this project. So for the demo, we're going to do a live demonstration, and then I'm going to touch upon the white paper, wireframes I used, ticket system, and feature branches that I followed. So let's get started. For the demo, we have a couple features. We can create an account and log in. We can customize our profile, upload images, and then we can update preferences and join a zip code that we're near, and then swipe on users in the same zip code. If we make a match, we can chat with those users, and then if we don't want to talk to them, we can block or delete the chat. So you can visit this demo. It might not be live on EC2 if I shut the instance down, but you can check out the source code on GitHub, link on the left, and also in the description. So let's go to the live link. So here it is. Welcome to Woofer. Let's sign in. We can also sign up with an account. Let's sign up with an account. So first, I'm going to do demo mail. Great. Let's sign up. And as we can see, we're on the home page, and we have the swiper card, but there's no users yet because we don't have a zip code. So we can add a zip code, or we can add pictures. Let's go to our profile. Link is also on the top right here. And we can edit our gender. So this is going to be a male user. Edit our name, our bio. I like treats. Our breed, let's say Shiba. We can add a zodiac sign and our group. So once we're done filling out the form, we can click update, and that will update the database with our profile. Next, we have images. So for a Tinder card, we can swipe through the image carousel up to 9 images, and here we can upload these images. So upload it, it automatically adds it to our account in the database. So upload a couple more. And then I can, if I want to reorder the images, what they are shown on the swipe card, I can just click these arrows and it will reorder them and automatically update that in the database. Let me refresh it and go back, and they're still there. If I don't like an image, I can delete it. And we can't click these buttons if it's the only image there. Let's upload another image. Perfect. So I can upload up to 9 of these, but I'm just going to do 3 for now. Next profile tab is the preferences. So your gender preference, you can only add one right now, but I could add a feature for both. And then here we can join a zip code. So let's join this zip code. Maybe I live near that. Maybe I live near some other zip codes like 102 or 10. All the zip codes you live near, and if I don't want to delete it, I delete it. Now, every time you click that, it's already updating in the database. Let me refresh it, go back, it's right there. Adding or deleting automatically updates it. So now that I've updated my profile, I can go into my settings, change my username, I can change my birthday, I can upload a new profile picture. Let me do that. Let's do that one. And it automatically updated in the database. I can remove it if I don't like it. And I can also send a password reset email as long as this email you have access to. Great. So let me go back to the homepage, and there's no users in our zip code yet because we just joined it. So let's sign up with another user. Log out. This is the home page, just some wireframes for demo purposes. So I'm going to sign up with a female. Perfect. All right, so we have a brand new user. We're gonna add zip codes to this profile. We wanted to join 106, I believe it was. And then we're gonna set our gender preference to male, gender to female, breed, let's say pug. When treat. Update our bio, save it to the database, upload an image for the slider. Nice, beautiful pug there. Oops. Alright, so add the zip code. Let's go back to the home page. So now we have the swipe card for this zip code because this user is nearby us. So we can see their profile, their name, details about them, and then we can slide through the carousel, see what they posted, in the order they chose. We can swipe yes on them. Now let's go back to the male user, demo male. Log in, and then we see the female is a swipe card for the male user now because this is a possible match. So let's click yes. Now both users swipe yes on each other, so we get a match made pop up. I didn't set a profile picture for the other account, but this is just the default. We can see their profile information in case we forgot who they were. And then we can open the chat. So here we can see the chat, and we can say send a message, which is persisted in the database. Before I show you that, refresh it. We have another modal. We can block the user, delete the chat, and then see their profile information if we want to check that out. Now let me go back home. If I go to the chats page here, we can see a list of all my chats available, and then the last message sent and their profile picture. We can also refresh this in case it's not working, it's not updating, and then I can enter the chat again. Now let me go to, all right, not now. There's no more users in the zip code, but we can go to chats and see the new chat created when we matched. So I can go to demo mail and say org. And this is a real-time chat with the WebSockets, updating client to client. These are completely different browsers and accounts, and all of this is persisted in the database. So I will refresh the page a couple times, refresh, back to the home page. All right, and then I'm gonna open up the chat again. We can see the last message sent. Open it up, all the chat history is still there. Now, let's say I don't like you and I want to block you or delete the chat. I will block you, and then if I try to refresh the chat, it's completely gone from both profiles because we don't want to talk anymore. And that's the Woofer app. All right, so I'm going to talk about the project organization, some things I did for the project. I created a white paper, which is a PDF file with all of the features and the technologies that I would be using to give the project some organization. I created wireframes with AcceleDraw to plan out the UI, have something to follow as I was building the React app. I created the logo with GIMP, which is basically open source Photoshop. Just some basic colors, nothing too crazy. And then for the project, for development, I used a ticket system with Trello, which is a in-browser ticket board that you can drag the tickets over and keep track of different features. And then for the development Git workflow, I use feature branches to work on it and then merge it back to the main, and the main branch has only working features. For this project, I use test-driven development, writing failing tests for an expected feature, and then building out the component or module to pass the test. And this helped identify bugs and maintain like a more robust backend API, as well as expected like behavior for the client when clicking buttons. All right, so now I'm going to talk about the technologies I used and how they all piece together to deploy the app. So things I'm going to talk about, technologies I use, the libraries, the app deployment architecture, how everything's deployed, the CI/CD pipeline database, the API, and a quick mention about test-driven development and the feature branches. So first, the technologies. Obviously, we have the MERN stack, and then I used Bulma for the styling on the front end. We have our testing frameworks for the unit and integration test, also the end-to-end testing. For the CI/CD pipeline, we build the Docker images and push them to Docker Hub, and GitHub Actions can automatically build and publish those, and then it's all deployed to the EC2 instance in the cloud. We also used Firebase for the authentication and storing some images for the users, and then the most important one was Socket.io for the real-time chat feature, which uses WebSockets. So here's a diagram of how everything is connected from the database to the API, which uses Firebase authentication when talking to the client, and then users can access the front-end React through the EC2 instance. So for Firebase, it's a backend as a service. You can use it as a database as only, or like as an entire backend. I didn't use this for the database though, mainly for authentication. I could show you here. We have the authentication for email password, storing the user information and storing cookies in the front end. And then the storage has images for each user. So for the database, we have the MongoDB Atlas in the cloud. This is a NoSQL database with JSON-like documents for easy updating and retrieval. We did not need a relational database for this project. It wasn't that heavy. So I settled with this MongoDB. Here in the portal, we can see our database here with all the different collections. And the NodeJS server connects to this. And this is also in the cloud. And here's a diagram of the schema we used, the different collections, each document, and the fields that they store. And for the database, we don't want to connect to the production database during development. And to get around that, we can run it MongoDB on localhost and connect to it there, store everything on our local device. And then in the test environment, we don't want to have to spin up MongoDB again and again. We can use a package called MongoDB Memory Server to connect to the MongoDB and easily seed the database and refresh it after every test, because we don't really need it to persist after the tests are done. So let's talk about the CI/CD pipeline. A quick mention, for development, I used linting and a pre-commit hook to enforce the code styles. So you can't push to the GitHub repository unless the code follows certain rules, like double quotes or single quotes, and it helps pick up minor typos before you push it to GitHub, and it keeps the code base cleaner. Really helpful. So for the CI/CD, I use GitHub Actions, and this is going to spin up a virtual machine, isolated environment, when you push to the GitHub repository, and it will check out the repository and install all the packages and run the code for us. So here, every single commit, we can see the check mark, which is the actions that run, and they indicate whether they pass or fail. Let me go to the Actions tab and see the last action. So here are a bunch of steps that the GitHub Actions automatically spun up a virtual machine for building, testing, and deploying the entire app, all automated. And if any step fails, you can see the exact step. So all integrated inside of my repository. So here's a diagram of the CI/CD pipeline. We have our local machine, local changes. We push them to GitHub. It uses the linter to verify that the code is following the code styles. It will build and test the app in Node, and then it will also build and test the Docker images, and it can run end-to-end tests running the Docker containers. Once those all pass, and we verify the code is working, we push them to Docker Hub. Here on my Docker Hub profile, I have a repository with the Docker image for the client and also the server. And once those are pushed to Docker Hub, then we can deploy it to the EC2 instance where we SSH into that machine and then pull the Docker images and then run the containers for the final deployment. So again, Docker Hub, that's another third-party service, but Docker or GitHub Actions will automatically deploy to that for us, and we don't actually have to go in that into the repository and make changes and push manually. So we have the EC2 instance, which is another virtual machine. It's in the cloud, and I can connect to it here in the portal via SSH. And if I run the Docker ps command, we can see 2 Docker containers running, which is the server and client that was pulled from Docker Hub. And this was all automated. I didn't actually have to start those manually. Only if I closed down the EC2 instance, I'd have to restart it. So the API, we have a backend API for the Woofer app, and it has some endpoints. I followed the REST API conventions, and I documented every endpoint as I built it. Let me go to the repository again. So in the GitHub repository, we can go to the Wiki tab and see a bunch of documentation. We have the API documentation for every endpoint, the method, expected response, and the code, all of that. So that's all in the repository wiki, very handy. And then let's talk about testing next. So this project, I practiced test-driven development, trying to get familiar with it, and I worked on testing the front end with React testing library and the back end using Supertest and Jest for both. So, and then also Puppeteer for end-to-end testing. More on that in a minute. So each of these are going to be running, can be running on localhost, but to test the front end for unit and integration tests, we don't depend on the back end to be running, vice versa for the back end. And then the back end is completely isolated and has MongoDB memory. So once the test environment is done, it's all scrapped and it doesn't rely on it anymore. So for the end-to-end testing, we actually do need the front end and back end already running. We can do that with npm start or Docker Compose running on localhost. We connect to it in a headless browser and then run it with and test it with Puppeteer and Jest. And also, one more thing to mention, the GitHub Actions will automatically do the end-to-end testing for us, and we don't have to, it's a hassle to set up locally, but the GitHub Actions can do that automatically, every commit. So, also reported the test coverage to a service called Codacy, which can analyze your code or your repository and track the coverage. Mainly, I just used it to track the coverage. GitHub Actions will automatically push the Codacy for us and keep that in the cloud. So lastly, the Git workflow. I tried to use feature branches, keeping track of each feature with Trello tickets, the ticket system. And then whenever I had bugs or issues, I created issues in the GitHub repository. You can view all of these on the Issues tab, closed, and I also tried to save all the relevant resources like Stack Overflow, answers, and documentation that I use to solve these problems so I can go back. All right, so let's talk about some of the engineering challenges I had during this project. Most of them were technical, learning how to set up Docker and Webpack and Socket.io, and then learning GitHub Actions. But besides that, there were some system design considerations and with the database that I had to plan out for this project. So first, I'll go over a challenge I had with the matchmaking system. Designing the end-to-end process of making a match with another user, and then when there was a mutual match, to create a new chat for them to talk with. I had to make a diagram because with all the code, something wasn't working, but I didn't know what was broken. And I had a few tests, but it wasn't catching the error. So I had to make a flowchart of the whole process, and then I wrote integration tests for every step. And then the few failing tests identified what steps were failing. And once I fixed those, the whole matchmaking system was working again. This is issue 95 in the repository if you want to look at that. So another design problem was creating an algorithm to pull users from a zip code and then return a random user from that zip code from the API. So there's an API endpoint to generate a possible match, but it was only working 10% of the time. And it would render a swipe card like this once it found a user, but it was having a very hard time finding it, giving the try again button. So I needed to refactor the endpoint and modularize each function in that endpoint. So it was pulling from multiple parts of the database and looking at that data and deciding what to do with it, but it was all jumbled in one controller file. So I had to break apart these files and then write tests for each of them again, more isolated. And then once everything was refactored, I was able to get it working. And after refactoring it, I also rewrote some of the algorithm. And before it had a 10% success rate, it was not working and it was very slow, over 1 second. After I redesigned the whole algorithm, it had 99% success rate with 350 millisecond response time. And that was a very important endpoint to generate possible users. That is the main feature of a dating app. So let me walk through some other challenges. I kept everything labeled with challenge or bugs in the issues and pull requests on the repository if you want to look through those. So here's the first challenge. As I was building the app, I needed to design the database and figure out how it would store user locations. Now, I had to decide what information I would store, like longitude, latitude, or like the state they live in, or maybe the mileage, the range where other users are away from them, and also whether or not to store this all in a SQL database or NoSQL database. Did it need to be relational? How do we keep track of existing matches? So after you get them from the location, like, have they already matched? So the solution I went with was using zip code pools. So every user manually enters the zip codes that they live nearby, and they join a pool of users that are all in that zip code. When we want to get a random user for a possible match, we just look at one zip code at a time and pull a random user from that pool, that list of users there. And then this could use a NoSQL database because we did not need it to be relational. And with the simple JSON-like format, we were just pulling user IDs and updating the records with simple updates. And with this, we didn't need complex queries. And the only con would be that it potentially takes up more space to store it this way. But it was very easy to develop with and write the endpoints for updating these the zip codes and user profiles. So next challenge I had was more technical with GitHub Actions. Now these are spinning up virtual machines, testing, building, and deploying our app. And with these, it's installing all the npm packages and setting up the environments over and over and over. Now, there are many repeated steps, and the main one was installing npm modules. Now, it was possible to cache the node modules and also caching the Docker images, because the Docker image build to take a long time. We can also try to run actions in parallel, but I ran into many technical issues with the GitHub Actions, and I was not able to speed these up very much. The only improvement I had was refactoring the GitHub Actions steps to make them clearer, more defined for building and testing, so it was easy to see which parts failed in the pipeline. So another big technical issue I had was getting Docker to build, working with React and Webpack, bundling the files. Now, the client needed to access environment variables, and to do this, it was referencing an env file, and it wasn't easy to put that env file in the Docker image. That wasn't going to work, and I needed a way to be able to reference process.env in the client Docker container. So the solution to this, eventually I found out I could use build arguments. So throughout the CI/CD pipeline, I pass along build arguments and secrets in the GitHub repository with the environment variables, so I did not have to use a .env file, and eventually it was able to pass these environment variables to the client securely. So another challenge was the deployment. So taking my code in GitHub Actions and getting it running on the EC2 instance. So GitHub Actions could SSH into the EC2, and at first it was going to check out the entire repository, download all the code, and then manually build Docker images. An EC2 instance has very limited resources, and cloning the entire GitHub repository was a lot of files, and that's not realistic for the little EC2 instance, and very slow, resourceful, and time consuming. So the solution was to build the Docker images in GitHub Actions in a virtual machine running on GitHub, build the image, publish to Docker Hub, and then once it's already published and built on Docker Hub, the EC2 instance just pulls a pre-built image and then can run a container. So next challenge was about security, where we had the front end and back end making requests to each other, and the front end used Firebase to authenticate a user and log in and store cookies, and the back end needed a way to verify that the request was from a logged in user. So from the front end, we pass along the Firebase tokens, and then on the back end, we verify those tokens as the requests come in, so it was only from a logged in user. And that's that. So those were most of the challenges I ran into and what I did to solve them. I'm going to highlight some improvements, next steps for this project that could be done. The main improvement would be redesigning the matchmaking system and storing user locations. Basically, the system design, just revamping that. There's usually always a way to improve a system. And then another improvement would be refactoring the deployment. So maybe isolating the microservices for the backend, that could help. And then also deploying the server and client separately. Right now, everything is in the same GitHub repository, and it gets kind of entangled. It's pretty isolated, but it's hard to read through the repository and if you don't understand it. So the next improvement would be more testing, more unit testing, edge cases, more end-to-end testing, and then lastly would be refactoring the code, just cleaning things up or making things more modular, basic things, and then maybe more code, different code styles, stricter code styles, and yeah, that's pretty much it. That's my Woofer MERN stack app. You can check out the code on GitHub. You can find more projects on my website. You can find my social medias here, and I'll probably be posting more project videos on YouTube. So if you enjoy these stay tuned. And that's it. Thanks for watching my project walkthrough of the Woofer full stack MERN app. You can find more projects on my website here. With the QR code, you can find my social medias. Feel free to reach out, leave a comment if you have any questions, and stay tuned for more.